Assalamu alaikum and good day. Alright, so now I'm going to proceed with the example for Euler equation and how do we solve the Euler equation. So I'm going to show you two examples in particular, and I've chosen these two examples for a particular reason. They're both going to be slightly different. Alright, so I'm going to start with the first one. So here the question said use the method of undetermined coefficient. So here it's already specified what method are you going to use in order to solve the equation. And we're going to use the undetermined coefficient method to solve the equation 2x squared d squared y over dx squared plus 3x dy dx minus 15y equal 9 log of x. And here, even if the question doesn't state the fact that this is Euler equation, because of this x squared right here and the x before the dy over dx, so we should be able to tell right away that this is not constant coefficient, so it's not going to be homogeneous and non-homogeneous equation, but in fact this is an Euler equation. Right, so now let's start with step number one. Okay, if you remember, so the first step is to identify the value of a, b, and c. So how do we identify the value of a, b, and c? So the number and x to x squared. So this is going to be your a value. So the number right in front of the x to the power of 1, that's your b value. And here this is going to be the c value. So now all you have to do is, so write down the fact that a, the value is going to equal 2, b, the value is going to equal 3, and c is going to equal negative 15. Don't miss out the negative. So that's the coefficient of y. Alright, so after you have identified a, b, and c, all you have to do is plug in into the formula. So if you remember, I said there's no need to memorize the formula, it's given. So you just have to copy down term by term. And it's given by formula of a d squared y over dt squared. So plus b minus a dy over dt plus cy, and that is going to equal some function f of exponential of t. Okay, so now what happens is that I'm going to use this formula and we're going to start substituting the value of a, b, and c. A is going to equal 2, so I'm going to have a 2, so d squared y over dt squared, and the value of b is going to equal 3, so here I'm going to have 3 minus 2 dy over dt. C is equal to negative 15, so I'm going to have negative 15y, and on the right hand side, so my function, which is f of x, now it has to be converted to be in terms of f of exponential t. So let me put it over here. So f of x is equal 9 log of x, and I'm supposed to convert this to f of exponential t. If you remember, what I did just now is that whenever I come across x, I convert that to exponential t. There goes my x. So basically this is going to be converted to 9 log of exponential of t. But we know log and exponential, they are the inverse of each other. So therefore I can actually simplify. The right hand side is going to be 9 of t. Okay, so simplify them. Well, it's going to look very complicated. It's going to be intimidating as well. Right, so basically, so this is my constant coefficient equation. So now let's simplify the part of b minus a. So my equation is going to be 2 d squared y over dt squared. So plus 1 dy over dt minus 15y, that is going to equal 9t. So this is going to be the equation that I'm going to solve, right? And of course, before I start solving, I have to identify whether it's going to be homogeneous or non-homogeneous. But because of 9t right here is not equal 0, so we know that this is a non-homogeneous equation, and it's even being specified in the question itself that we have to solve this by using the undetermined coefficient method. So that will be step number 2. Okay, now I'm going to do the undetermined coefficient method. Of course, when we're using the undetermined coefficient, there will be two components. So the first one is going to be the yc. So my characteristic equation for this case is going to be 2m squared plus m minus 15 equal 0. So this is going to be the case of, let me try to factorize this. I think it's going to be the case of distinct roots. So I'm going to have here 3 and 5. This is going to be plus and a minus. So yeah, I'm going to have negative 15. So that will be 6 minus 5. So this is going to be the case of distinct roots. So my first root is going to be a value of 5 over 2. And the second root is going to be a value of negative 3. So now beware that our variable is y and t. So that is the equation that we're solving right now. So yc of t is going to equal a exponential of 5 over 2t plus b exponential of negative 3t. Right, so that is going to be our yc. So now we can move on to the second component, so which is finding the particle integral yp. So our yp is going to depend on the function on the right hand side. So our function f of exponential t is given by 9t. And so when you have a polynomial, so when we wanted to find a family of derivative, we always look for the highest power of the variable with highest power. And for this case, it's got to be t to the power of 1. So therefore, my first element is going to be t to the power of 1. And when I differentiate, I will get 1. So we're going to stop right there because we know that the rest is simply going to be 0. So now I can write that my yp of t. So that is going to equal, so dt plus e. Right, so that is going to be my yp. And of course, remember, every single time you use undetermined coefficient method, you have to check for linear dependency. And if you remember what I did in class is that I removed the constant a, b, d, and e for this case. So when I remove the a, that's my function. Remove the b, this is my function. And d, and this is actually e multiplied by 1. So I noticed that none of them are the same. So automatically they are linearly independent. So yes, so we can use this as our yp. Every single time, like whenever you use the undetermined coefficient method, right after you've written your yp, make it a habit for you to check right away for linear dependency between both of them. And of course, like how do you tell whether you are actually having a problem with linear dependency? You are unable to compare. Like for example, for the case of polynomial, the highest power on the left and the right hand side is not the same. So that is a hint that you're doing something wrong. Alright, so now let's differentiate this twice. So my y prime p of t, that is going to be given by d, and the y double prime, when I differentiate d, that is simply going to be 0. So now let's substitute this into the original equation. So I'm going to have 2 multiplied by y double prime, that's a 0, plus y prime, so that is going to be a d, and minus 15y, so that's minus 15 multiplied by dt plus e. And that is supposed to be compared to 9 of t. Okay, so now I'm going to start by collecting the variable with the highest power, which is for this case is going to be t to the power of 1. So on the left hand side I have negative 15d, and on the right hand side I have a value of 9. So straight away we can tell d is going to equal negative 9 over 15, that negative 3 over 5. So that is my d value. And then I'm going to do the same for t to the power of 0. Basically, I'm just going to collect all the constants. So I'm going to have d minus 15e, and that is going to equal 0 because there's no constant right there. So therefore, so this is not 15. This is actually minus 15 of e, and that is what actually we're looking for. So from here I can write that 15 of e. So that is going to equal d, which is negative 3 over 5. So therefore my e value is going to equal negative 3 over that. But I can cancel it. It's going to become negative 3 over 25. So that is my e value. Now that's going to be negative 1 over 25 because I already cancelled the 3 and the 15. So that's negative 1 over 25. Right, so now that I have the yc and I already know the values, the constant values for yp, so I can start writing down the solution, for which now I know that y of t, so that is going to equal a exponential of 5 over 2t, so plus b exponential of negative 3t, and I'm going to combine that with the yp, so which for this case is going to be negative 3 over 5t, so plus e, which is going to be negative 1 over 25, so that is going to be our yt. So we're done. So we have solved the equation, and this is going to be our solution. Yt is our solution. Alright, so step number 3 is, remember, so we have to convert this back to be in term of x, because the original equation is in term of y and also x. So we're going to use the substitution, the third substitution. X is going to be replaced by exponential of t, or like if you come across t in the equation, so log both sides of the equation, and that is going to equal log of x. Let me write this the other way around so we can see that clearly. So exponential of t is going to equal x, or x equal exponential of t. That's basically the same. Alright, so now let me highlight all the places that we're going to substitute. So basically that's all the terms with t in there. So here, this one and this one as well. There's no t right there for the last term, so let's just leave it be. Okay, so before I start converting them, so let me rewrite it first in the form that we can easily convert. I'm going to write that. So a exponential t to the power of 5 over 2, because straight away now I know that this is simply going to be converted to be x. And then I'm going to have a b exponential t to the power of -3, so minus 3 over 5t minus 1 over 25. And now I can easily convert this to become y of x. So this is now going to be a x to the power of 5 over 2, and this is going to be b x to the power of -3, so minus 3 over 5 log of x and minus 1 over 25. So that is going to be our final solution. And of course, for these cases as well, there could be two types of solution, which is particular solution and general solution. And for this case, because our solution has a constant of a and b, so this is going to be general solution. If the initial conditions are given, it's going to be two of them, because we need to find two values, a and b. So all you have to do is substitute, use both initial conditions, find the value of b, and update your equation. And that's it. That will be a particular solution. The idea is pretty much the same. Okay, so that is the first example. All right, so now let's move on to the second example. So as I mentioned just now, this is going to be slightly different. So here it says solve the following Euler equation. So we have an equation of x squared d squared y over dx squared plus x dy dx is going to equal 1 over log of x. So if you notice the right hand side of the equation over here, this is not equal 0. So we know that this is a non-homogeneous equation that is solved either by using UC or VOP. But for this particular equation right here, for this particular question, it is not stated in the question itself, so what method that we're supposed to use. So meaning by, so you have to decide based on our conversion later, so you have to decide what method is going to be the most appropriate for this following question. So now let's start. So let me start with step number 1. So here my a value is going to equal 1, my b value is going to equal 1 as well. And my c value, there's no y function right here. Basically, it's 0y. So my c value is going to equal 0. So substitute into the equation, which is going to be a. So that's 1 d square y over dt square plus b minus a. That is going to be 1 minus 1 dy over dt plus 0y. And that is going to equal 1 over log of exponential of t. Okay, because here remember, so f of x is going to equal 1 over log of x. So my f of exponential t is going to equal 1 over log of exponential t. So let's simplify this right away. So here, because log and exponential is going to cancel each other, so I basically going to end up with 1 over t. And when we simplify this equation, so this is actually going to be d square y over dt square plus 0 dy over dt plus 0y, in fact. So the right hand side of the equation is going to equal 1 over t. So that is actually a simple function of d square y over dt square equal 1 over t. Alright, so because the method is not mentioned, you have to decide on your own. So what are you going to use in order to solve this non-homogeneous equation? So can we use undetermined coefficient? The answer is no, because remember, the undetermined coefficient is only for polynomials. Polynomials are when your variable is raised to a positive power, but this is not the case because 1 over t is basically t to the power of -1, so it's not a polynomial. So you cannot use the method of undetermined coefficient. So the only way to solve this is by using the VOP method, version of parameter. So now let's start solving this by using VOP, step number 2. And similarly to undetermined coefficient, so when we wanted to start solving the equation by using VOP, so it's going to start with the YC. But YC is very crucial for VOP because your whole calculation dependent on it. Like if you get it wrong for YC, automatically like your whole calculation is going to be wrong. So be careful with the YC. My characteristic equation is going to be m squared equals 0. And this is basically going to be the case of equal roots, m plus 0 squared equals 0. So my first and second root is going to be a value of 0. So this is the case of equal roots. Yc of t is going to equal a plus bt exponential of 0t, and because this is 1, so that will be simplified to a plus bt. And if you remember, the next step is to identify the value of y1 and y2, and for this case, let me put this a little bit distant to each other so I can easily show them to you. I'm pretty sure you know it by now. So this is a plus bt. So the next step is to identify y1 and y2. So y1 is going to be the variable right next to a. You just remove a, and whatever that goes after a, that's your y1. You remove the b, and what goes after b, that is going to be your y2. So now all you have to do is you're going to differentiate both of this. So y1 prime, so when I differentiate 1, that's simply going to be a 0, and y2 prime, differentiating a t, that is going to be a 1. And we're going to need those values to find the Wronskian, so let's rearrange that. Y1 and y2 goes on top, 1 and also t, the derivatives go right underneath 0 and 1. So this is going to be 1 multiplied by 1 minus t multiplied by 0, so that's a 0. So my Wronskian is going to be a value of 1. That's a simple value. And remember, I told you before, please simplify Wronskian. At your level, Wronskian should only be one term. If you come across something with like a bunch of terms together, something is wrong with the calculation, or you need to simplify them. It's going to be either the two. Alright, so now I'm going to start finding the u and the v. So u is going to equal negative integration of y2, and my y2 is going to equal t multiplied by f of t, which for this case is going to be 1 over t, and over aw, that is going to equal 1 for this case, our value of a, and our value of Wronskian is also 1, so dt. And when I simplify, of course, t multiplied by 1 over t, I will end up with negative integration of 1 dt, which is negative t plus integration constant c. So that is going to be the u function. And then I proceed to finding v. So it's going to be integration of y1, so which is going to be 1 multiplied by 1 over t over a multiplied by Wronskian. And this is going to be integration of 1 over t dt. This is raise a rational function to the power of 1. This is the special case where it becomes log of t and plus integration constant d. Okay, so now we are almost at the end of our calculation. So all we have to do is put that according to the formula. So the formula is uy1 plus vy2. So u is given by negative t plus c multiplied by y1, which is a value of 1, plus v, which is going to be a log of t plus d multiplied by y2, which is going to equal t. And actually there's no need to expand this because it's not that we can actually simplify this. But if I were to expand this, I'm just going to end up with a function of negative t plus c plus t log of t and plus dt. That's it. So that is going to be our function. Or you can actually simplify them a little bit further, because here this is t and t, so I can write this as c plus et plus t log of t, and what is going to be e is just actually d minus 1. Okay, so because if I were to factor them out, so I'm going to have d minus 1t right there. So just to make it clearer, let me write it down. So these two together, it's going to be d minus 1t, and I actually represent this by a constant e, or you can just leave it like the one at the top right there, so that's fine as well. It's up to you. Okay, so that will be our solution. Right. However, don't forget step number 3. Step number 3 is converting it back to be in terms of x. So here I only have a bunch of t to change, and so it's going to be c plus e log of x plus log of x log of log x, right? And that is going to be the solution. That's it. So that is how it's going to look like. Okay, so that is going to be Euler equation. So basically, if you understand the previous topics that we've discussed before, Euler equation shouldn't be a problem to you as well, because basically the method is still going to be the same. You're using the same method, you're applying it back, but just step number 1 and step number 3 is going to be different because you're going to be converting the variable. Alright, so I'll see you in the next video.